anybody understand me properly? Am I speaking loud enough for you? Or, yeah, does it work? All right. I am testing this Keynote app for the first time, so please bear with me that this is going to work somehow. Otherwise, well, I'm sorry. All right. I'm very happy to be invited to be talking about capturing the world in 3D beyond OpenStreetMap in a way that, well, I am a hobbyist after all, and I'm accompanied with a lot of experts in the domain today. This gives me a lot of freedoms, especially to tell you a lot of very foolish stuff, so the experts can freely correct me anytime soon. So the damage I can do to you as an audience is very much limited. So instead of the talk or the title that was originally given the technical overlap between what I was originally to present and what I'm now going to present, I decided that I will put a certain focus on economics. Because I believe that it is not being talked about often enough, especially in a technology sense or in a technology perspective. And I will do so by starting with making some very bold claims. And one of the claims is that I believe that mapping costs will approach zero very soon, like 5 years from now, to give an exact date. And I will try to somehow show you why I believe this is the case. And most importantly, what I find really interesting is that there is a shift going on, especially with drones, that more and more map data will not be created for use or by humans, but rather by machines themselves. And that the human scale maps will probably be more like a side effect of the map mapping for machines. But before I start, I would really like to do a very hands-on approach. Let's say you have a drone and you have taken some pictures, and I will really briefly just skim through this because we already had this. You probably end up with pictures like this. This is a construction site, given you are a fan of construction sites and drones. Here's probably another image that you would really like. There are a lot of pipes lying around and people will probably be really much enjoying this. But sooner or later, as a drones fan, you will probably stumble upon the fact that these images only give you a very limited view of the world. Especially they are very limited in size, and probably you want a 3D model. And as we just learned, there's a lot of open source software available. And there's another project called OpenDroneMap. And OpenDroneMap was started about a little bit more than 1 year ago. And it is, it self-describes as an open source toolkit for processing drone imagery. And this is exactly the perfect explanation you can give. It is quite an active project with so far 31 contributors contributing to it. It's fully open source. You can clone it on GitHub, and most importantly, it takes about 10 minutes to install on a bare-bone Ubuntu machine. And you just run this single script inside a single directory where you have all your drone images, and it basically is done. So how does it look like, or what does it actually do? So, given from a set of example images or images that you have taken with a drone, it outputs all different sorts of data, especially a point cloud, as we just heard. It also generates orthophotos. It also does georeferencing and gives you even textual digital surface models now that you can view in MeshLab. And this is what it would look like if you would have processed all these images and taking a look at the textured digital surface model in MeshLab, and to give you an experience that it actually generates 3D models. You can probably see that the original data is just vertical imaging. So what you can see here is actually a rendered picture. The quality is not super good. This is also partly because of the original data is not of such a high quality. But just to give you an example how this looks like without textures, and that it actually generates a 3D model, just this little mesh view, and taking kind of a zoom in part of the street. This is how it looks like, so to say, without textures. And this is a sparse point cloud from which actually the software generates this and this, but we already learned this just some minutes ago. But here's the point I want to make. with about 80 pictures. That's the number of pictures that were being used for this overview that you just saw. Processing these 80 pictures takes a little bit more than 1 hour on an EC2 machine. And well, there are certain problems with the current implementation. But basically, it is pretty fast and it will be much faster in the future. That is already known by now. But when you are a drone enthusiast and probably also heavily involved in OpenStreetMap, you might ask yourself the question, okay, what am I going to do with these pictures and that I just computed? And the answer is OpenAerialMap that started this year by the humanitarian OpenStreetMap team. It actually got a grant, so a lot of people are now working on this, and you can use it just by going to beta.openaerialmap.org. There you can find some example imagery, also from drones, and it has a very nice, user interface. So you can just search and filter. For instance, I was searching for Kathmandu here, and you can probably see the different colors and the overlays here. And as soon as a certain kind of blue, so to say, appears on the screen on the map, it means that you can actually find some imagery. And all you need to do is select an area, and you get a download dialog, this one, and you can freely download the map data. They are also working on all sorts of different ways to access this, for instance, using QGIS and other GIS applications. But again, wrapping it up, OpenAerialMap is actually a pretty sophisticated technological product and project. They have done a lot of nice abstractions in a way that as a owner of these map data or of imagery data, you can very easily participate in a federated network, and the OpenAerialMap project will then index the data for you and offer it all through the beta or OpenAerialMap.org site. And more importantly, they also worked on stuff like licensing, etc., etc. So it really is a coherent product and a project. Leveraging latest technology is actually worth a visit. But I said I would like to take a look at economics, and there is a certain pattern to notice looking at all these different projects. There's OpenDroneMap, it's fully open source. There's OpenAerialMap, again, it's free hosting. It goes on and on. There's OpenTerrain and all other projects now starting, which are all focusing on a certain type of data or problem in all that space of imageries and drones. And more importantly, you can also just literally download an open source operating system and package for running and automating drones. There's open source hardware available. So something really interesting is going on here. And let's get into the economics right away. So more or less, if you spend about $1,000, you will get a drone and a 4K camera, which is not so much, I would say. And if you want to store 250 high-res images, meaning 4K, that costs you about 1 cent a month when you're using Google Cloud Storage. And for some reason, this thing is really going crazy. Okay, oh, wait a second. All right. So, if you want to process these images, this takes you, well, actually much less than 2 hours, but processing these images for 2 hours costs you 40 cents at Amazon EC2. And if you do the math, if you have a 4K camera, etc., you can cover quite a significant area with 250 pictures. And again, this is just for showing you or for giving you an idea what I'm trying to come up with now. So if you do the math and say you were 5 times a day surveying an area, each time the area surveyed is 0.2 square kilometers, you end up with a daily cost of about $3 or $90 a month, or just a little bit more than $1,000 a year. So this is with the 3-year amortization rate for the drone. Interesting things happen here. As you can probably see, the drone is not actually that costly anymore, speaking of the total cost data processing and all this stuff. But more importantly, even data storage is basically a free thing compared with the total cost. And more importantly, the data processing can be highly optimized still. So the software that is being used is not using GPUs, for instance, and there's a version that they actually reverted, but for most cases was actually accelerating or was cutting the data processing time by about 50%. So let's say you cut down the processing cost by 50% and get a 50% cheaper drone, you actually cut the cost by 50% in total, effectively. So, and the other thing to obviously note here is that the total cost in terms of IT, if you will, is not super high and is really affordable. And now to put this into a certain scale, because I cannot really imagine how huge an area of 30 square kilometers is. The Bezirk Friedrichshain-Kreuzberg has about 20 square kilometers. And by the way, with just a single drone and given this equation, you need about 2 months to map the district of Mitte and Friedrichshain-Kreuzberg, costing you less than $200 by this model. But this is not where I would like to stop, actually, speaking of economics. Let's be a little bit more ambitious and say, okay, let's map the whole district of Berlin. And I would like to have a refresh rate of let's say 1 year. And with 1 year, I mean every square meter is being visited at least once in a single year. By this model, and again, this is simplified, but basically it gives you the dimensions that we are talking about. You need 3 drones and about $300 a month to do this mapping. And if you want to visit every area in Berlin at least once a month, you need 30 drones and $3,000. And again, it goes on and on, and you can see things here. I don't know the exact cost for mapping or for creating the 3D model of Berlin that exists right now. There are some rumored numbers. I think there is somebody from Berlin Partner here who can probably shed some light on this later on. All I want to say is, I mean, a daily refresh rate is obviously probably a little bit too much, but I mean 12,000 euros for a weekly refresh data set, and this is the total cost, right? I mean, this is including storage. It's not that much. That's what I want to say. And to get some, or to give you some more ideas what this means from an economic perspective. Again, these numbers are in a certain way speculative, because I don't know exactly how expensive operations for an airplane is, for instance. But the number for Landsat are actually correct with regard to that's what NASA says for themselves. So this gives you a certain scale and a feeling. Again, it is just about the scale that I want to come up with. And it gets even more crazy. I stumbled upon this yesterday, and I would like to tell you that this drone costs $19. Now, this is probably not geoscale. Drone thing with a high accuracy, but here's the thing. An iPhone baseboard fits inside this drone, and the iPhone baseboard has everything you need to potentially drive such a drone. There's a 4-core, inside this baseboard, there's a 4-core CPU, there's 7 gigabytes of memory, there's a gyroscope, GPS, a chip, and all that stuff that would potentially fit inside the smartphone already now, right? So this is not, I mean, I'm not talking future or some 5 years away. Potentially this could work, yeah, literally right now. And again, this drone is $19. That's even with shipping, by the way, that is free shipping. You can buy the drone free shipping. It's from China. And I have no idea whether this would actually work, but I actually ordered one. There are some consequences from this. Again, I'm a hobbyist, so all I can say is that obviously, speaking of Leica gear, for instance, this is quite expensive gear. It's not $19 gear, right? So this is a different K-class kind of gear what Leica is offering, to give an example. The question really is how much accuracy do you need, and how much accuracy can you approach by repeating the surveying? And this is probably the trade-off to be made here. And I would not even claim that this is my idea, but the idea of replacing high-class, high-end gear by very small and simple wimpy machines is something that Google featured and Google made very famous. They completely thrown away these 5-figure servers and replaced them by the cheapest servers, or actually desktop machines they could find. And probably the same is going to happen to the geo industry with all these very inexpensive drones. I mean, a $19 drone that probably ends up costing you $100 with all the sensors on top is so cheap it's probably not even worth to pick it up when it's broken. You probably just leave it as kind of an electronic garbage, and somebody will probably find it and repurpose it. But basically, again, the question is how much drones do you need for how much accuracy and how much will it cost you? But it completely changes the game, right? The second thing is, say there is a $100 drone that is good enough and is flying autonomously, or automatic, as I just learned, flying automatically. How does it change the game? And I would say it completely turns the mapping game upside down. Right now it is a human-driven thing. Humans go to a place, carry out a certain task, and it is quite costly in the end. Now, if you have a completely automated system, the question is, does it still be the same? And most likely this is going to change. Meaning, you probably just send out a drone and get the jobs done, and it becomes, in the essence, a $0 effort. Why? Because the drone is so cheap, the processing is so cheap, and since these drones are so cheap, you can deploy hundreds of them in a city and just send them to a place where you need them at a certain point in time. This is the equivalent of, let's say, a taxi or a Uber for autonomous drone-driven surveying. Similar things are actually being developed now by certain startups. But what is really interesting to me is that most likely the data acquisition cost will be much slower than the derivable value from the surveying, which means, again, this is so to say another way to explain that surveying is a zero effort or a zero cost effort. This is pretty much the same kind of thing. But when this happens, again, I believe the game changes in a way that not people start to question, should I do a surveying or not? But it's probably more of a question like, how often do we want to do the surveying to keep it economically feasible, so to say. And there's another thing going on. I mentioned it before. Maps used to be something that is being carried out by humans as a tool of exposing power, essentially, and it was something that is being done for humans ultimately and by humans. Now, machine vision, and we have actually an expert right over here. With machine vision, this thing completely changes. The type of maps autonomous systems need are not really comparable with the maps that humans need. So this has the implication that maps have to be built specifically for autonomous systems. And this is being done already by now, and this will be done much more often. As I mentioned, when drones become cheaper and cheaper, the map creation process in itself will also become cheaper and cheaper, and maps will be made specifically for autonomous systems. This is happening already by now for cars. Will probably also happen for drones very, very soon. And I believe that there will be so many different autonomous systems in place because they are going to be so super cheap and so useful that the map mapping will be really like 90% for machines and probably less than 10% actually for humans. The questions I have is when will this sub $100 drone thing happen? Because I truly believe that this is just a matter of time, because it's already, everything is there basically, it just has to be put together and pushed in a quantity that you actually get to that level. But technologically, I don't see any big hindrance here. The question I have is, and I think there will be another talk on this, what will legislation do, or what will the government do when these ultra-affordable drones can and will be deployed more or less everywhere? And so what will happen then? And you probably have seen this week, or actually last week, that Canon has announced a 250 megapixel chip. And so again, things are, the economics are working, so to say. So the megapixels on affordable chips is scaling very rapidly, again driven through the smartphone industry. So it is really, from my understanding, just a matter of time when like hundreds of megapixel chips will be affordable, and affordable in such a way that you can put them in a, let's say, $1,000 drone. And again, the question is, how does it change the game with such incredibly high resolution, or with such incredibly high resolution imagery? And what will this do with privacy? I mean, with a 250 megapixel camera, you can probably determine whether a certain person has skin cancer or something even more crazy. And this is probably possible in the future, and it ties to all sorts of privacy questions. So wrapping it all up, drones are quite cheap, and the economic works for drones, basically. And again, there's, as I mentioned 2 times before, there's a historic power shift taking place in terms of maps. I find this quite remarkable. Mapping cost, I hope you agree, will approach $0, or mapping process cost will be basically 0. And the interesting thing, I believe, about 3D maps is that they are not actually going to be made for humans, but for machines. Again, I find this pretty interesting, and that's it. Thank you.
Again, questions? Okay. I think it was an interesting aspect on how this automatic, maybe also later automated capturing will work, also the whole workflow. Maybe I have 1 or 2 questions.
Yeah,
where do you actually see the next frontier into this process? So what is the next business that will be disrupted by this automatic 3D capturing? Because I mean, we saw some examples right now, terrains, and measurement, but is there maybe an industry which is directly impacted by this technology shift?
that's a very good question. I mean, the case that I made up is more or less, or when there are sufficiently high enough number of drones being deployed and autonomous enough in the city, let's say, then for many tasks you would probably no longer even need to have a person or a surveying person in some way in the field. So probably the people who are doing surveying will probably be most affected by this, I would assume. But beneath the obvious examples like maintenance and construction, I believe that that maintenance processes that will be highly disrupted by this. But there's no other industry I can think of right now that will be probably so much affected.
Okay. And maybe the second thing that I had was also an interesting discussion we had in preparation for WACA. Is this maybe correlated also with the dramatic increase of 3D printing capabilities? I mean, we have capturing, right? And usually when you have, it's like a carbon copy, right? So you make a copy, but what you have in the end result, you want to duplicate it. And now we are in the process of capturing the data. But what about a carbon, 3D carbon copy of whatever building? Is this something?
I have no idea actually.
Okay.
Because I cannot really think of what would be the benefit of doing this. But what I can definitely see is that completely different technology though, but I mean the small scale replication is obviously going to be a big thing. Like something is broken and probably just put it somehow together and do the 3D scan and get a 3D printed spare part. I mean, this will probably be a big thing in the future, I would assume. Actually, a good friend of mine did this for his dishwashing machine, and he saved a fortune doing this, actually. So this is already happening. The spare parts industry will probably be very much affected by this, especially everything that is plastics. Yeah. So, but what this has to do with drones, I have no idea actually.
But I think we encourage someone to
Just a general comment. Do you see the government introducing legislation that might curb?
I think there's a legislation expert talking about to me. I have no idea, but actually, I mean, I would say. As soon as a politician gets spied on with a drone, I would assume that something will change. And this will probably happen very soon. I'm just a cynical, but seriously, I mean, this is, I believe, will be the latest point when actually legislation will take place.
The reason I ask is probably the worst situation you could probably be under is something happens and a swarm of collective networks, drones are pretty small. A swarm of drones come and do their thing or whatever.
Yeah.
And there's proven, I think, psychological and biological studies on the effect of pervasive drone activities in the area.
Yeah, that's also what I'm thinking about actually. I mean, I have given specifically the example of that $19 drone because it's actually feasible with just a little bit of money to perform an attack on something. Whatever the attack means, it's probably more psychological than actual damage. But this is feasible, and I have a hard time to think of a system that could actually prevent this type of attack, like a security system. So when this happens, again,
I've seen movies where they send out an electromagnetic pulse or something.
Yes, yeah, probably they have this by now, or by then. That's also, that's a good idea actually. EMP type of thing.
Yeah. Cool.
But sorry.
How does the bandwidth of data transmission relate to the processing time? So, is it a problem?
Well, I have a fairly high upload speed with my DSL line at home. And so the mission that I described, where you're conducting five flights a day, it's actually feasible to upload this per day using a regular DSL line at home. It's actually doable. And I mean, if you have plenty of processing capacity at home, you probably don't have to upload the stuff anyway. It is an issue, but I really believe it can be solved in that sense. If you were to do this pervasively, you would probably even make a proper contract with a mobile carrier, and LTE gives you enough bandwidth to, especially since it is a distributed thing, you would not end up overrunning a single set tower.
Okay. But it was one last question.
Is some potential for use in VR, like there's a lot of research in VR, like capturing video with like camera mix of multiple cameras at once. And if these things fly around, maybe there's some potential for capturing content for VR situations.
Absolutely. I mean, I think we saw a drone with a stereo camera attached on this before. So it's absolutely doable. I mean, I'm pretty sure that people are actually doing this. I mean, it would be an easy for a startup to get a lot of money saying, okay, we are doing this movie thing with drones and VR, and you know. So sooner or later somebody will try this. Seriously. So I haven't done so, but these cameras are super lightweight, and there's no problem in just putting two of them. Two GoPros, right? I mean, you can just.
I've seen this week like 12 of them.
Yeah, but this is a completely different. This is a completely different thing, right? This is 360-degree So what I'm talking about is, so to say,
Stereo.
stereo, and this would be already enough for VR. Right? So,
Yeah, then
Thanks.
thanks again, Martin.